Is it possible that space and time existed separately to one another prior to the Big Bang?
You have never noticed a time unless you were at a place.
Right.
And you've never been at a place without having noticed a time.
Right.
So why should we believe they were ever separate? What would it even mean?
For them to be separate.
To be separate. It's not clear. I don't know what it would mean to have a universe without time.
Right.
How do you have events that follow other events?
Right.
Is it just frozen there forever? I don't know. I'm not convinced.
Right.
But if the universe is constantly expanding, Neil, doesn't that make measurement irrelevant?
So the measurement would be in this moment, right? In the current epoch. Yes. Yeah. So, well, how big is the universe? You might hear some people say, well, it's 13.8 billion light years to the edge. More precisely, and this is where we get into the weeds, that is how long it has taken the light to reach us, emitted by objects on our horizon. Over that time, the universe has expanded. So you can ask a different question and say, how far away is that object today? We don't see that. And so I'm raised in you only talk about what you can see camp. And so we see the galaxies on our horizon and we say they're 14.8 billion light years away.
Is time real?
At half-life limit, let's make sure we're on the same page. There's certain elements that are radioactive, which means they decay into different elements. Right. You start with a blob of one element, and if it has a half-life of a week, let's say, that means in a week, on average, half of those atoms will have turned into a different kind of atom. And it drops rapidly. It's 2 to the n power, right? So it drops rapidly. So if you have 10 half-lives, then you have 1/1000th of what was there before left over. So it's basically 1,000th of what was there. All right. You can take an element that has a half-life and accelerate it to near the speed of light, and its decay will be delayed by the exact amount that you calculated in Einstein's relativity. Whatever internal clock tells atoms to decay, that is affected by relativity. So time is real.
If we ever get to move to Mars, will we be stronger and faster?
That's an odd question to answer. Because the question is, are you stronger than what? If 2 of y'all go from Earth to Mars, whatever your strength ratio was here on Earth,
it's going to be that
on Mars. So we have to be precise about how we're going to answer that.
Right.
Okay?
How much stronger will I be as an individual once I land on Mars?
All right. So we got to benchmark it. So let's say on Earth, you can lift 100 pounds.
Okay.
Okay? We have to ask, what does that 100 pounds weigh on Mars? Weighs 40 pounds.
Right.
So on Mars, you can lift more than your 100 pounds.
Right.
Because it doesn't weigh as much, not because you're stronger.
If the Earth center wasn't hot and there was a hole all the way through, what would happen if you jumped in?
Because if you dig a hole through the center and you start in the northern hemisphere, you have to end up in the
southern hemisphere.
In the southern hemisphere.
Right.
If you start in the western hemisphere, you got to end up in the
eastern hemisphere.
That's how the geometry works. We'll dig a hole and we'll land in the South Pacific. So you jump in, you will fall and accelerate continuously until you get to the center. You'll hit peak speed. Now, what happens to you? The hole is all the way through the Earth. You will overshoot the middle. And now Earth will slowly slow you down. You are slowing down continuously. And in the exact rate that you had sped up going in. You're going to fall back down and you're going to repeat this forever.
I want to know if there's such a thing as absolute stillness in the universe.
Kelvin, when he became Lord, he was Lord Kelvin.
Right.
A brilliant physicist, a little cocky, but brilliant. He pioneered the Kelvin temperature scale, which is the absolute temperature
zero.
scale.
Right. That's
so what they found was, at any given temperature, air molecules are vibrating, or they're moving among and bouncing off each other.
Okay.
If you drop the temperature, they move a little slower. And so he extrapolates it. There must be a point where they stop moving at all.
Okay.
If they stop moving at all, there's no temperature left. Absolute zero.
Nice.
You can't have temperature less than the temperature of something not moving. Completely reasonable before quantum physics. Quantum physics says you try to take it to the lowest possible energy state, and you cannot characterize a zero energy state. There's always some fluctuation.
Something is moving.
Fluctuating.
Or fluctuating or
I
doing
want to distinguish sort of vibration from translational movement.
Exactly.
And I'm thinking he means translational movement. Is there a point where nothing is moving?
Right.
Okay? So, the answer is no.
The edge of the observable universe. What observations have been made?
The age of the universe is in our way.
The age.
Yeah. So there's a horizon beyond which we cannot see because the universe isn't old enough for light from objects beyond that horizon to have reached us yet. As we look out into the universe, we see the universe younger and younger and younger and younger until we see it just shortly after the Big Bang itself. So generally, when we speak of the universe, it's how big is the observable universe? We don't know. No reason to think it's completely different. No reason to think just beyond your horizon, there's something very different from the water that you're witnessing up until the horizon. No reason to think that. So too with the universe. Beyond an observable horizon, no reason to think the rest of the universe is fundamentally different from what's within our own horizon.
If the singularity of a black hole is a moment in time, can I escape if I bring my time machine?
Yeah, so the answer is yes. Okay, you're a place you don't want to be.
Okay. All right.
And somebody locked the door. Now you say, well, how do I get out? Well, a fourth dimensional person will just say, step into the fourth dimension.
Right.
I don't have access to the fourth dimension.
Right.
I don't even know what that means. I don't know what your word for up means when that takes you into your fourth dimension. So we can say that. All right. Now, time is a fourth dimension.
See what I did
It's
there?
not a spatial dimension, but it's nonetheless a dimension.
Right.
So if you were in your enclosure and you had a time machine, you could go back in time before you were in
the
room.
enclosure. Right.
And escape the room without ever opening the door.
If humans were to be graded on our understanding of the universe, what grade do you think we should receive?
We know enough about the universe to quantify our ignorance. If you look at everything that we have mastery of, you know, the molecules and atoms and gravity and all of this, and you look at what's driving the universe, everything you learn about in school in science is 4% of the universe. That we see things going on in the universe, we can measure them, and we have no idea what it is.
If I rotate a proton fast enough, can I create a black hole?
Just because you spin something has nothing to do with whether it becomes a black hole. They're
Right.
unrelated.
It's
all about mass. That's A. B, a proton is not a fundamental particle. Okay? A proton is composed of quarks. And so let's create that question, reassemble that question in a way that has meaning. If a black hole is evaporating by Hawking radiation, and let me remind people, the gravitational field just outside the event horizon has enough energy to spontaneously create particles, a matter-antimatter pair. And one particle drops into the black hole, the other one escapes. Where did this mass come from? It came from the gravitational field of the black hole. And the gravitational field comes from all the mass that is the black hole.
During the Big Bang, what went bang? If we don't know, what are your best guesses?
There's only one answer here. It's the universe went bang.
When we say particles collide to create virtual particles, do they really fist bump each other down at the Planck scale?
Because of electromagnetic forces, which hold your body together. When I go up to Charles and I touch him, if you actually analyze what's going on at the molecular and atomic level, I'm not actually touching him. There are forces in a field surrounding the particles, and it's the forces that are bumping off each other. And this impact parameter exists when there are fields that surround the objects that
Hang
are
on a
coming near
second.
each other.
What are good ways to wrap your head around partial or even complete vacuums? For example, space. Like,
There's a deeper question there,
go ahead.
and it's what is nothing?
What is nothing? Yeah.
The best vacuum we've ever created was in the detector, was it, of the Large Hadron Collider. We do okay with our vacuums. You leave our atmosphere very far between the planets, that's an even better vacuum. That vacuum has one particle every cubic meter. If you take away that particle, then what is that? Is there nothing there? No, there is still something there. The laws of physics are still there. If you want a place where there's nothing, shouldn't you be removing the laws of physics as well? Now, there's no particles there.
Okay.
There is light passing through it. Through that volume is the fabric of space and time. It should have no virtual particles. It should not even have a space-time continuum. And if it doesn't even have that, maybe that's how you get rid of the laws of physics.
If a superintelligent extraterrestrial offered to grant you the answer to one specific question, what would you ask?
There's a question I have every night.
Go ahead.
Is the human brain sufficiently smart to figure out the entire universe?
Wow.
That's a question I want answered. Because if it's not, then I'll buffer my expectations.
Right.
But if it is, then
We
onward we
can
march.
go from there.
Right.
But living in 3D space, can we ever actually observe a truly 2D space?
Holding aside the fact that if you're 2D, you have no thickness.
Right.
If you have zero thickness, how does any light or matter even interact with you? Because light and matter
Reflect.
Yeah. Okay. But
right.
so let's just ignore that very real complication, but let's ignore it for the moment. A 2D world in front of us would be completely visible. You would see light reflecting off of their substance.
Right.
Their 2D substance, whatever that is.
Right.
Only when they go sideways do they disappear
Okay.
from your view
Right.
because they have no thickness. So, we three-dimensional creatures, what would four-dimensional, spatial dimensional creatures be able to see us? It means there must be some orientation we can take where we disappear to them.
Supermassive black holes at the heart of galaxies hold the key to understanding how galaxies come into being. That entire galaxies will inevitably end up being swallowed by their own black holes and disappear forever.
No. A black hole is really tiny relative to the galaxy. They're big. They're like the billion solar mass black holes are like multiples of the size of the solar system. But that's still tiny in the
Compared
middle
to
of the
the
galaxy.
galaxy.
Okay.
Right.
If it's going to eat the galaxy, the matter that's orbiting it has to stop orbiting and fall straight in.
Right.
And that's just not going to happen.
No, it's not. So when two galaxies collide, do the black holes then actually fall into one to another and become one giant black hole around that galaxy?
They will very likely eventually find each other. When the galaxies collide, they will pass through one another.
Right.
It'll be this cosmic ballet choreographed by the forces of gravity. And it'll pulse like that as they pass through each other, come back, collide again, and they keep doing this until it settles down. Because there's energy dissipated each time that happens. And the settling down puts the heavy stuff in the middle, the heavy, slow-moving stuff in the middle, and the faster, lighter stuff in the outer region. That's when the system is settling.
Right.
And the black holes, they're the heavy thing in the middle.
Of course.
So they'll find each
They
other
find
in
each
the
other.
middle. They'll merge, and you'll get a black hole twice the size you had before.
Is the Trantor Star Bridge or any type of space elevator technically conceivable? Jeff Seitz in Gallatin, Tennessee.
Okay.
Or Gallatin, Tennessee.
The answer is yes.
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 But so some things to take note of.
Okay.
The motivation for a space elevator is you can get to an orbit without ever firing a rocket.
Yeah, there you go.
You just, all right,
You just get on the elevator.
get on the elevator. What is an entire floor doing of just lingerie?
Yeah, exactly.
Nobody's asking that question.
Right.
So on Earth, a space elevator would take you to the geosynchronous orbit, because that's the only orbit that appears to hover over Earth.
Right.
Its corresponding spot on Earth. Any orbit that's closer, it will speed up ahead of the orbit of the Earth.